Hi, Year 12. So today's video is looking at the dot product. The scalar product is also called the dot product. And the reason it's called the dot product is the way we write it, it has a dot between the vectors. So if we had two vectors, vector u, which we'll call x1i, y1j, and a second vector v, which we call x2i, y2j, then the scalar or dot product between those two vectors would be defined as this little equation down here. We'd have u dot v, so that's where the dot comes from, and we'd be multiplying the x parts of each of those vectors and adding to that the multiplication of the y parts. Please note that we add them, so we're not getting another vector when we multiply by the dot product. We're getting a value, and that value cannot be drawn. It's just representative of the product of those two vectors, and it's going to allow us to assist us with finding some other information about those vectors, like the angle between them. So, again, we'll say u dot v, there's our u, there's our v. We get our x parts, our x components, multiply them together, and add to that the y components. And that formula is given to you on your HSC formula sheet. So let's have a look at this one here. We're going to find the scalar product, u dot v, given that these are our two vectors, 2, 0 and 3, 0. There's a picture of them drawn there, so they're parallel vectors. If we were to multiply u and v by the dot product, we're going to multiply our x's, which is the 2 and the 3, and then we're going to add to that the multiplication of our y's, which is the 0 and the 0. So we end up with 6 plus 0, which is 6. That is our answer. I don't want a vector, I don't want 6, 0. We need to add those two parts together. We'll have a look later on about perpendicular and parallel vectors, so we're not going to talk about that here. That'll be in the next video. Right now we want to go and find the scalar product or the dot product of the following sets of vectors. So A, we've got two vectors u and v, 2i plus 3j, I minus 2j. So to find the dot product, we're going to multiply our x's, which are 2 and 1, multiply our y components, which are 3 and minus 2. Add those together, we get minus 4. Similarly, with the other two, these are vectors, okay, so we're finding the dot product of those two, 4 times 2 plus minus 3 times 0, and we get 8. And lucky last, the same for the last one. Multiplying our x's, multiplying our y's, and adding them. In this case, we get 0. So that's fairly straightforward. Okay, so if we move down to the next sheet in your booklet, we're going to have a look at the angle between two vectors. So this will now jump to the 1001 in our Maths in Focus book. So in order to find or work with the angle between two vectors, we need to look at the dot product formula. And the dot product formula is now got an extra part into it. So just up above, we looked at the dot product of two vectors u and v was equal to the sum of the x components plus, the sum of the multiplication of the x components plus the multiplication of the y components. But it also equals this. Okay, the magnitude of our vector u times the magnitude of our vector v times cos of theta. So we can use either of these methods to find the product. This one's the easiest if we have our vectors, but if we want to look at the angle between them, we're going to need to use this one. And down below, I want to have a look at the derivation of where that formula comes from. But just have a look to the side here, just to note, we looked at magnitude previously. The magnitude of a vector is the square root of the x squared plus the y squared. So the x component squared plus the y component squared of that vector will give us the magnitude of that vector. And we're going to need that to work out where the proof comes from. So to formalize this proof, we've got two vectors u and v, and they're drawn so that their tails meet at an angle theta, and there they are there. So there's angle theta between those two vectors. Now, if we were to use our parallelogram method, we could write this red vector in here as our vector u minus our vector v. Now, if you don't like the parallelogram method, I could rejig that as the triangular method. There's our u, okay, there's our resultant vector. In order to get, I need from here back to the tip down here, I need a negative v. So it's u minus v. So we've got this set of vectors here. Now, if you remember back to your last year's lot of maths, when we looked at the cosine rule, we're going to basically pop the magnitude of our vectors into the cosine rule and use that to come up with this new formula up here. So the cosine rule was a squared equals b squared plus c squared minus 2bc cos of a, where the angle A was opposite the side A there. So we've got angle theta here, and it is opposite the side u minus v in our vector. So we're going to write the u minus v, or the magnitude of that, as our a in that formula. So the magnitude of u minus v squared is the magnitude of u squared plus the magnitude of vector v squared minus 2 times the magnitude of u times v times cos of the angle between those two, which is opposite the u minus v. So there's the cosine rule here. Rejigged, I'll just highlight it for us. Okay, so we need to add the information in there that we have specific to our vector. So if we've let u be the vector from up above, where we let vector u be y1j and x2 relating back to vector v, what we'd have here for our magnitude of vector u minus v, we'd have x1 minus x2 all squared, so the difference in the x components squared plus the difference in the y components squared. Now, if that one is something you're not sure about, have a look back over here. Okay, we remember that was our magnitude of our vector. If we square both sides of that, we're going to end up with, just change pens here, what we have in our formula there. So if I square this side and square the other side, okay, I basically got the squared part of my vectors there. So what I'm doing here is replacing my magnitude of my vector u squared with x1 squared y1 squared, and the magnitude of my vector v squared with x2 squared y2 squared, which I've got shown to you over here. Minus 2 vector u, 2 magnitude vector v, cos of theta. Okay, so we're not going to expand these ones. If we were then to expand this out, I'm going to get this little part in here. Okay, square the first, square the last, twice the first times the second, square the first, square the last, twice the first times the second. That's what I'm going to get for that expansion there. And I've still got my right hand side. So what you'll see is that vector cancels with that one. That one's going to cancel with that one. We've got y1 squared cancelling and y2 squared cancelling. So what we're ending up with on the left is minus 2x1 x2 minus 2y1 y2. And our right hand side has the minus 2 magnitude of our u and v cos of theta. So we've got it a lot neater now, and it's workable. Factoring out minus 2 on the left and cancelling with the minus 2 on the right, we end up with x1, x2 plus y1, y2. We've got our 2 magnitude vectors here, cos of theta. And then what we also know from our previous page is that when we sum the multiplication of our components, it's also the dot product of those 2 vectors. And there we have our final formula. So let's put that all together. So what we end up with is the dot product of 2 vectors u and v is equal to the magnitude of that first vector u times the magnitude of that second vector v cos theta, and it's also equal to the sum of the components x multiplied together and the y multiplied together. Now that is given to you on your HSC formula sheet, so you don't need to memorize that, but you might like to remember how that's come about, that formula, and then you might, you will then need to look at how to use that formula. So moving down a little bit further into the example, we've got 3 vectors, u and v and w. Okay, I won't read them out. You can see their components there quite easily. If we want to calculate the dot product of u and v, we're going to take our x components and multiply them, take our y components and multiply them, and then add them together. There's my working out down here on the left. If I do that, I end up with minus 43. So that's A done. Part B says find the angle between those 2 vectors, v and u. So when they're talking about angle, I need to think, well, I can't use this first formula now. I need to think of it as the second formula, or the second part of that formula. So I want to look at the u and the v, the magnitude of them, cos of theta. And I know that equals this. And I actually have worked that part out in part A. So I know, okay, that first part is minus 43. I can work out the magnitude of u and v, pop in cos theta, and then invert my angle to find theta. So let's do that. The magnitude of our vector u is the sum of each of the components squared and taken the square root of. So that would be 9 and 49. Go back to our vector. That's coming from minus 3 squared is 9, minus 7 squared is 49. Add them, square root them, and I've got 58. Similarly for my vector v, we'll go back to that vector. I've got a 5 and a 4 as my 2 components. If I square each of those, I get 25 and 16. Add them, square root them, and I get a root 41. So I need to pop those 2 answers into here. I know that that equals minus 43 from my last part. There's my magnitude of u, root 58 times root 41 cos theta. Divide both sides by the surd parts there. Invert my angle and I get theta is 152 degrees. And that's the angle between those two vectors. Okay. Part C is saying show the distributive property holds. Now you might not remember what the distributive property is. You learned the distributive property back in year 7 and all that said was A times B plus C is equal to AB plus AC. The same will happen with vectors. Vector V dot product with the sum of U and W is the same as, I'll put my arrows in there, dot product of V and U plus the dot product of V and W. And all I've done on this side, and I'm not going to go through all of it, is basically worked out each of those dot products. So U and W vectors, we just add those components, and we learnt that a couple of lessons ago. So double check that you've gotten that to I minus 11j. Now I'm working out what the dot product of V and that U plus W vector is. So I've got my V vector dot with my U plus W there. We're going to multiply the X components, which is 10, multiply the Y components, which is minus 44, add them together. We get minus 34. I'm just going to double check the right hand side. Dot product of V and U, dot product of V and W. Double check you're happy with those. When I add them together, I get 30 minus 34, which is the same. So left hand side is right hand side. So the distributive property holds. The last bit to have a look with on those notes is just a scalar product of a vector with itself. And this is actually really quite easily. Instead of having U times V, I've just got V times V, or V dot V. And instead of having the magnitude of U times the magnitude of V, I've got the magnitude of V times the magnitude of V again. Now, the angle there between those two vectors, if I'm multiplying a vector with itself, it sits on top of itself and there's no angle between them. So the angle between the vectors is 0. What's cos of 0? That is 1. So that part disappears and I just end up with the two vectors dot product together equals the magnitude of each of those times together. And what we've done over here is just basically taken the square root of both sides. And I might just write that down there just to make sure that you see what's happening. So what that means is I've got vector V times vector V is equal to the magnitude of V times the magnitude of V. So that means it's vector V's dotted together, the magnitude of V squared, taking the square root of both sides, I just end up with V dot V is equal to the magnitude of V. So that's where that one's come from. Have a look at that, make sure that that makes sense to you. And I want you to go back and have a look at the exercise belonging to this, but I also would like, I say that again, I also want you to go into the OneNote and have a look at the Chapter 8 work solutions that I've worked through for you from the Cambridge textbook, which is a little bit harder, okay? 8C question 8, I want you to work through there and feel confident with that. I'd also like you to have a look at 16. 16 is a little bit harder, but you can work through that, and I think that you need to be able to be at that stage, so please work through that one. And I've also got some of 18 in there as well. So I want you to go and work through those, as well as the other exercises, and see how you go. If you need to use my notes to do that, please do that, but I want to be sort of confident with those style of questions as well.